Welcome back to the second part of this tutorial on how to detect the gesture of the controller. In last episode, we learned how to create a list of points from the player's movement, and in this video, I will show you how to use this list of points to feed a recognition algorithm. Okay, so to use this list of points that we have here for making a gesture that can be recognized by our algorithm, we first need to write at the top here using P $gesture recognizer. Perfect. And now finally, in the end movement function, the goal now is to create the gesture from the position list. Perfect. And so for this, we need to create a new array of points, which I will call point array, and that we can initialize with new point array and with new point bracket here. And here for the length of the array, we need to give it our position list dot count, so that the array of point here will take exactly the same size as the position list count. And now the next thing to do is to populate here this point array. And so for this, I will create a for loop. Instead of length here, we need to write position list.count. And so now with this for loop, I can do point array, take the index I, and populate it with the position list element I. But as you can see, this creates an error. So there is a difference between a point element and here the element inside our list is that the position list is a vector 3, but for the point, we actually need to only have an X and Y value. And so here is all the problem that I talked earlier with our algorithm, is that our algorithm works in 2D and that our controller works in 3D. But this is not an issue. What we can do is project the point in 3D towards the player using something like camera.main.where-to-screen point and give it our position list element. And so this will give, and so this will create a vector 2. So I don't want to write here the point array, but it's instead vector through screen point. And finally, using the screen point, we can create the point array. So point array I equal new point screen point.x and screen point.y. And finally, we need a third parameter, which is the stroke ID, so the number of strokes that we made. For now, we will only focus on creating gesture with one stroke, so I will write here 0. And there you go. So this way, as you can see, we have created a point array from our position list by getting the position on the screen from the position of the movement that we made with our hand. So there is actually other type of projection that we can have, but I found that this method works really well with this algorithm, so feel free to give it your own taste. Okay, so now that we have a point array that is filled with the position list, we can create a gesture with gesture new gesture equals new gesture and give it our point array. Perfect. And now we can actually do two things with it. Either way, we can create the new gesture as you saw from the demo scene, or we can recognize this new gesture. And so here we will first focus on creating the gesture. So for this, I will go back to the top of my script. And here under the debug queue prefab, I will write two variables. The first one will be a public bool variable called creation mode, and which we can set to true at first. And this creation mode parameter will say if we are creating a new gesture or if we are trying to recognize a new one. And so the next parameter that I will create is a public string variable called new gesture name. And so when we are in creation mode, this parameter will be the parameter that we will be using to give a name to the new gesture that we will be making. Okay, so back to the end movement. So now that we have created the gesture, we can use it to either add it to our gesture library or recognize it. So if creation mode, if we want to create to add this new gesture, we can do new gesture dot name equals new gesture name. And we want to add it to the list of gesture that we currently have. So I forgot to add it to our variables. So we can write below private list of gesture, and I will call this training set. And so now back to the end movement function, we can do training set dot add and add here this new gesture. Okay, so this was to add a new gesture to training set. Now to recognize, we can simply do result equals point cloud recognizer dot classify. And here, as you can see, we need to give it the gesture candidate. So in our case, it's our new gesture. And give it as the second input, the training set. And there you go. And so here we have an error because it doesn't want it to be a list. It wants it to be an array. So I will write to array here. And there you go. This fixes our little problem. And now in this case, as you can see, we will be the result, which will tell us which gesture it is, but also the score of the recognition of this element. So we can write it in the debug console with debug.log result.gesture class, and then write result.score. And so this will first write the result name and finally the score that we have to the console. Okay, so here you go. As you can see, we have made it so that when we are ending the movement, we either can create the new gesture that we made, or we can either recognize it. So let's go back to Unity to test it. Okay, so I'm going to click on play. So we are currently in creation mode. So to create a gesture is actually really easy. We now simply need to give a new gesture name. So for example, I will give this one O, perfect. And now we can draw the gesture with the controller. So let me grab this controller by there. And now I can simply draw an O. Perfect. And as you can see, we have a little error, and it's because I'm really dumb and that I forgot to initialize the training set. So for this, we simply need to go here back to the top and do equals new list of gesture. Perfect. Okay, so we are in creation mode. So let's make sure that we have here this enable. I will give the name O for the next gesture that we will be making. And now I can draw a no. And there you go. Now, as you can see, the movement has ended. And we have now a new gesture that has been recognized. And now let's see if we leave creation mode, if it will recognize this O gesture. So let me just uncheck this. And now if I draw a no, as you can see, it worked. It finally worked. This is so great. So as you can see, after ending the movement, we have recognized the O gesture that we just made with a 0.98 score. So that's really working well right now. But we have an issue with our training set right now. So as you can see, if I leave play mode, so if I try to play the game once again, and that I leave creation mode first, if I drew a no like I did just in the previous play, as you can see, we have no match here showing on our console windows. And so here the issue is that the training set doesn't return the gesture between the different play that we'll have. So we need to find a way to store the gesture in our game file, and this is what I'm going to show you now. Okay, so let's go back to our script. So here, when we are creating the movement, we can actually store this movement in our file using something from the P recognizer asset that we made, which I think is awesome. So first, we need to create a path where we want to store our element. And so for this, I will create a new string called file name, and which will be equals to application.persistent data path. So this is a persistent data path that remains even if you are building the game. Then we can add next to this string a little slash. I will then write the new gesture name, and then I will write .xml. Perfect, now that we have the file name, we can write the gesture in this file name using gesture.write gesture. So as you can see, we need to give it the point array. So I will write point array and then the gesture name. So new gesture name. And finally, the third parameter is the file name. So file name. And so now that we have created and stored this gesture in our file, we need to find it at the start of the game. So here at the top of the script in the start function that was empty, what I'm going to do is try to read all of these gestures. So to do this, we actually need to add at the top here using system.io. Then in the start function, I will create a new string array called gesture files, and which will be equals to directory.getFiles. And so we can here give our application.persistent data path and write star.xml. So what this will do is find all of the data paths that ends with .xml here in the application.persistent data path folder. And so with this, we can do for each loop, and instead of the collection, add the gesture files that we have. And finally, we can feed the gesture files here to our training set. So we will do training sets.add and do gesture.io dot read gesture from file and give it our item. And basically that's it. We have now finally found a way to store the gesture and then recognize them. And so if you want to know where this file is located in your folder while we are still using Unity, you need to go here to user, app data, local default company, and then movement recognizer, which is the name of the project I'm making in Unity. And as you can see, I have here the two movements that we made while trying the algorithm, so the left triangle and the X. And so, for example, you can delete them. And so let's see if this creates correctly the gesture while in the game. So let's go back to our project. First, let's make sure here that the creation mode is set to true. Now I will click on play. And so let's create some gesture. First, I want to create a no. Perfect. So that's one movement. Now I want to create a nem. Perfect. Now I want to create a wave, for example. And now there you go. If we go back to the folder, as you can see, this has correctly saved and create an XML file for each of the gestures that we made. And so now if we leave play mode, and that I leave here the creation mode, if we try our game then, as you can see, it correctly finds that this is a no. It currently finds that this is an M. And here it knows that is this a wave. And so everything is working, our gestures are recognized and are stored in our XML file. And basically that's it. We have made it possible to trigger any behavior that we want with a particular gesture. And so now you can basically do what you want with this. And so for example, let me show you how we can easily use this for any behavior that we want. I will add for this two variables, a public float, which will be a recognition threshold, and which I will set to 0.9 maybe. And the second parameter that I will make is a Unity event, which will be called when we are recognizing something. But I want this event to actually retain the name, the string name of the gesture it has recognized. And so for this, we need to make a custom Unity event. So let me show you how you can make this. First, you need to add using Unity engine.event here at the top. And then you need to do public class Unity string event, and here inherit from the Unity event that takes a string parameters. And now with this class, you are able to use a Unity string event that can retain as a variable a string parameter. So we can do public Unity string event on recognized. Perfect. And finally, you need to add at the top here system.serializable. And now if we save and that we go back to Unity, as you can see, it is showing right there, and we have the unrecognized string Unity event that we can use, and that will use a string parameters in its function. So this is really handy if we want to use the unrecognized function from outside of the script. So let me show you how. Let's go here in the end movement function, and when we are recognizing a gesture here, we can first check that this result exceed the recognition threshold with if result.score is above recognition threshold. And then in this case, we can do on recognize.invoke and give here in the input of the invoke the result.gesture class. And there you go. This way, the unrecognized function will be called only when the result exceeds the recognition threshold. And there you go. Now basically we can click here on the plus button and use any function that we want to be triggered when we recognize. So in my case, before recording this video, I've already prepared a prefab here called object spawner that I can drag in the scene. And this prefab is actually really easy. It contains only one script with 4 child with a name that match a particular gesture. So O, M, wave and X. And here in the object spawner script, if we open it, as you can see, it's really simple. It just contains a spawn function which will activate the game object that has the corresponding name from its variable. And so if I click on my movement recognizer and that I drag my object spawner over there, we can choose to trigger the spawn function. And this way, when we recognize a gesture, it will spawn here the corresponding game object that we want to show. So let's see if this works by clicking on play. So let's draw a no. And as you can see, it worked. The script correctly called the object spawner on the smiley face, which show here the smiley. And we can do the same for the M. And as you can see, it works. And there you go, guys, congratulations! You managed to make a gesture recognizer in VR. Thank you for watching this video till the end. As you can see, for now, our gesture recognition only works with one stroke, and so we are not currently using the full potential of the algorithm, and the reason is that we are calling the recognition of the gesture directly after the player releases the input button. So if you want to allow multiple strokes, an easy way is to delay the recognition function. And if you guys are interested by this, you can leave a comment below and I can share a modified version of the script that allow this. And I'm really curious to see what you guys will make with this gesture detection system, so don't hesitate to showcase your work on the Discord server, link in the description below. A big shout out to my Patreon. Without you, I wouldn't be able to make this video. And if like them you want to have access to the source code and exclusive content, join us, the link is in the description also. Anyway, thank you for watching and see you in the next one.